Welcome back to the GCSE Maths Pro YouTube channel. Today's video is part 2 of the angles topic, where we'll be specifically looking at angles in polygons. So there's one main formula that you will need to know for this topic. You've probably forgotten about this topic because normally you do it in like year 8, maybe year 9, depends on your school, and you've probably completely forgotten that it even exists, but it can come up in GCSE anyway, and the formula definitely won't be on your formula sheet. So the main formula, if you want to work out the total angles or the total degrees in any polygon, let's break that down first of all. Polygons are just 2D shapes, right? So any 2D shape, including pentagon, hexagon, heptagon, octagon, you know, that kind of thing. Any 2D shape is a polygon. It's just like an umbrella term for those shapes. And for example, you should already know that the total angles, total degrees in a triangle is 180. And in a quadrilateral, which is a 4-sided shape, is 360. Those are the two that you should have memorized. Beyond that, we don't necessarily need to memorize it because we can use this formula. Now, this formula does work for triangles and quadrilaterals as well, but those two you should already know. So you're going to do 180 multiplied by n minus 2. Now, n is the number of sides. So just for example, a pentagon has 5 sides. If you wanted to know what the total degrees or total angles in a pentagon is, you would do 180 times 5 minus 2, which is effectively 180 times 3, and that should give you 540 degrees. Okay, you don't need to memorize that pentagons add up to 540 degrees. You can just use this formula for any 2D shapes. Now, this second one here, as you can see, is basically the same at the top. We just added a little bit extra. That would be for any polygon. It could be a regular pentagon where all of the sides are the same, so, roughly something like that. Imagine that all of those are the same. Or it could be a pentagon in terms of this. This is a pentagon, isn't it? We've got 1, 2, 3, 4, 5 sides. That's not regular though. Either way, all of them should add up to 540. But in a regular pentagon, obviously all 5 angles individually are the same. So if you want to find out the interior angle, so one interior angle in a regular polygon, so any shape where all of its sides are the same and therefore all of the angles are the same, you would do 180 times n minus 2 to work out what the total is, and then just divide it by the number of sides to find one of those angles. So those are the main 2 formulas. They're basically the same thing, just a little bit extra here. Now let's actually go through some questions so you can see what we're talking about and how to use them. So here we've got work out the sides of angle x in the heptagon. So a heptagon is a 7-sided shape, and naturally we're not going to have memorized what all of these angles should add up to because it's a heptagon. We don't necessarily have that one just off the top of our head. So I'm going to use the first formula here to work out what all of these 7 angles should add up to. So we had 180 times n, which is in this case 7 sides, minus 2, and that should give me 900 degrees. So I know for a heptagon, for any heptagon, this is obviously irregular, but any of them, it should add up to 900. Now I'm only missing one angle, so all I need to do then is 900 minus all of the other angles. So we've got 80 plus 165 plus 159 plus 89 plus 132, finally plus 124. You're just going to type all of that into your calculator, and that leaves me with 151 degrees. So that is x, because there was only one missing angle, and it has to add up to 900. So that's a basic example to start with. Okay, now we're making it slightly more complicated, but still very similar. We've got here that angle A is twice the size of angle B. Work out the size of angle A. So here we can check what shape we've got. Again, it is irregular, but that's fine. So we've got 1, 2, 3, 4, 5 sides, which means it's a pentagon. So I'm going to do the same thing. I'm going to work out what the total degrees in a pentagon is. I know we've just done it, but let's just say we didn't just see that. So 180 times by 5 minus 2, which is effectively 180 times 3, which gives us 540 degrees for a pentagon. Now though, this is the bit that's kind of difficult. How do I split this up? Because A and B aren't exactly the same. I like to bring algebra into it. You might want to use a ratio. I always label the smallest angle with x. So B is obviously the smaller one, right? Because A is twice the size of B. So A is 2 times as big. So if that's x, what does A have to be? And I'm deliberately using the same letter here in terms of x. If that's twice the size, that must be 2x. So do you see how I could create an equation here? We've got 77 plus 149 plus 71 plus the other two angles, which is x and 2x, we know that that must equal, or must add up to, 540. And the reason why I've used the same letter, so I've not used x and y, for example, to show the two different angles, is because I only have one equation. If you've only got information to give you one equation, you can only use one letter. If you had enough information for two equations, two different equations, you could use two, like simultaneous equations. But we don't here, so that's why I'm using x and then therefore 2x. So if I simplify this and add up all the like terms, collect the like terms, so we get 297 plus 3x. It's literally just an equation, so I just need to solve this. So 3x is therefore equal to 243, and then divide by 3, x is 81. Now the only thing here is that when you've solved the equation, you can kind of think that that's the final answer. Just double check. That's what x is, so we know that b is 81. However, do you see that the question was work out the size of angle A, which is actually 2x. So therefore, to find angle A, I just need to double 81, which is 162. And there we are. There's my answer. So we can also use a bit of algebra if you find that helpful as well. Okay, so this one is just work out the interior angle of a regular hexagon. So the interior angle, if I draw a hexagon here, regular again means that all the sides are the same. So that's the same. All, in this case, 6 sides are the same. And if all 6 sides are the same, then all of the angles inside must also be the same. So when we say interior angle, we're referring to literally just these angles that are inside. It's obviously got 6 equal interior angles because of the keyword regular. So to work out basically just one of these angles, we're going to use that second formula that we had at the start. So you can build it yourself, you don't necessarily have to memorize it. I obviously want to know what all of these angles add up to in a hexagon, and I don't necessarily know that off by heart. So I'm going to use my formula, 180 times by n, which is in this case 6, minus 2. Now that would give me the total of all 6 angles, but I actually only want to know 1. And because I know that all of the angles being regular are equal to each other, they're all equally distributed, I can just divide this total by how many angles or sides that there are. There are 6. So it's the same formula, I've just kind of added this extra bit to work out just one angle when it's specifically a regular polygon. So effectively the total of all of the angles is 720, and then if you divide that by 6, we get 120 degrees for each of these angles. Again, I know I'm repeating myself, but this is specifically for regular polygons. This method here wouldn't work if you've got an irregular one, like some of the previous ones we've seen. So that's an interior angle. The next question is now the exterior angle. So work out the exterior angle in a regular octagon. So if we get an octagon here, again, regular, meaning that all of the sides are the same, therefore all of the angles are the same. Now, we can use our formula to work out the interior angle. However, we are looking for the exterior angle now. Now, sometimes you might think that the exterior angle must be the bit on the outside, but actually it's not that. If I were to continue a straight line here, the exterior angle is this part. So not the whole of the outside, but if you imagine that each of these carried on as a straight line here, straight line here, straight line here, it's all of these little bits. So first we need to work out the interior angle, and then we can use that to work out the exterior angle. So we're going to use the same formula, 180 times 8 minus 2 in this case, over 8 to work out one interior angle. So the total degrees in an octagon is 1080, therefore individually each interior angle is 135 degrees. And if you've seen our previous video, which I will link now if you haven't, but also it'll be in the description if you want to check it out at the end, we should know how to work out the angles on a straight line. Angles on a straight line, that whole thing there, add up to 180. So if I know that part of it's 135, all I need to do to find out the rest of it, the exterior part, is 180 minus 135 in this case, which leaves me with 45 degrees. So that is the exterior angle. Okay, really straightforward, but if you didn't know what it was, again, you might assume that the exterior angle is all of this. That's what I assumed when I first saw it. But it's not. It's as if it were on a straight line. So now we're moving on to a slightly more advanced question. We've got here that each interior angle for a regular polygon is 144 degrees. work out the number of sides the polygon has. So do you see how now they've given us the interior angle, and we're effectively going to have to work backwards to find out the number of sides originally. That's why they said polygon and not being more specific. So we're going to use the second formula because they have told us the interior angle specifically, one of them. So we're going to do 144 is equal to 180 times n minus 2 over n, this time because they've given us one interior angle for a regular polygon, not the total of all the angles. So I need to divide it by n. So I've set up my equation. They've asked me to work out the number of sides, which is n. I've got an equation with just one letter, so that's perfect. I know it appears twice, but it is the same letter. So now I can almost forget about the context and just solve the equation. This is just algebra. So I'm going to want to get all of the n's together on one side of the equation and all the numbers on the other. Because this is a linear equation, it's just n, it's not squared or anything harder like that. So I'm going to first deal with this fraction, because fractions are always quite annoying in equations. I'm going to multiply by n. You can always move the letter itself, that's fine. So I'm going to multiply by n to move it across, and therefore I'm opening up this fraction, it's no longer there. Now, depending if it's a calculator question or not, you can either divide by 180, but obviously that's going to end up being a fraction. Or, what I would recommend if you don't have a calculator, if it is a non-calculated question, is just expand the brackets. So 144n is 180n minus 360. Now, it's looking a little bit better, but I still have n in two places. So I want to have a positive number of n's. I'm going to move the smallest value, which is 144, across. So we get 0 is 180n minus 144. Leaves me with 36n minus 360. I'm going to move the 360 over to make it positive. So we got 360 is equal to 36n. The last thing I need to do is divide by 36. So I get 10 is equal to n. Now, it says work out the number of sides. The number of sides we know is represented by n, so that is just my answer. There are 10 sides. So, in other words, it's a decagon. So this is why this formula is so important, because we can also use it to work backwards if they ask us to work out number of sides. If they ask you whether something is possible, they say this is the interior angle, is it possible? You're looking to get a whole number. Obviously, you can't have a decimal number of sides. It can't be like 2.5 sides, can it? It has to be a whole number of sides. So your n value should always come back as a whole number. If you get a question like this one where it comes back not as a whole number, you've done something wrong. Just go back and check. If there's a question where they say, oh, there's this value for interior angles, is that possible? Then you can work it out. If you get a decimal, you can say, well, no, that's not possible, because it has to be a whole number answer. So just double check that one. This is now our final question. Sometimes they draw some polygons for you. They use some of these angles on the outside as well. And then they have this kind of mystery polygon. So here we've got work out how many sides the regular polygon has. So we've got a regular hexagon specifically here. We've got two values for the angle, and then we've got a regular polygon. So it's going to be similar to the previous one, except there's now more work. In the previous one, we were told what the interior angle was for this mystery polygon. We could work it out from there. So I need to know that in this case, but I need to do some work to even figure that out in the first place. So I know this is 55, I know this is 50. This is all around a point, isn't it? Angles around a point. Again, if you've seen that first video, add up to 360. So that's telling me, okay, to work out this one, I need to use the angle in the regular hexagon and then subtract everything from 360. So the first thing I need to do is work out the angle of a regular hexagon. From this video, you might have seen that we've looked at it before, but let's just pretend that you're starting from scratch. So 180 times 6 minus 2, because I want to know only one of those angles, and it's regular, I'm going to divide by 6 as well, which should give me 120 degrees. So now I know that this one is 120. Do you see how I've only got one missing around that point? So we can use 360 degrees minus all three of those, 120 plus 55 plus 50. That will give me the interior angle for this mystery polygon. So there I have 135 degrees left for my regular polygon. And now I can do exactly what I did in that previous question. So I know that I've got one interior angle is 135. Again, it is regular, so that's fine. And I can set up my equation, 180 times n minus 2 over n, because it is just one of those angles. and just literally solve this. So let's just rub this out and give us some more space. Okay, so I'm doing exactly the same as I did in the previous one, so I'm just going to whiz through it. Obviously, I'm going to multiply by n, and at the same time, I might as well just expand my brackets. Then I'm going to swap the 360 and the 135. So 180 minus 135 is 45n, and then I just need to divide. N is 8. So work out how many sides the regular polygon has. Well, it has 8, it's actually an octagon. And there's your answer. So as long as you memorize pretty much just this first formula and then just be aware that sometimes you can also add in the divide by n in the context of a regular polygon, that's basically the whole of this topic. If you ever see anything about polygons, it's probably going to be this formula some way or another. But make sure you do memorize it because it won't be given to you in the exam, and then, how are you supposed to work it out if you haven't memorized all of the shapes, which is obviously unreasonable to do. We just need one formula and it will tell us the total angles in any 2D shape. So thanks for watching this video. If you found it helpful, make sure to like and subscribe and leave down below any questions or comments you might have. The final part of this series is going to be angles on parallel lines, so make sure to check that one out next as well.